Okay, so we are at day 2. We will be continuing the system design interview prep for the topic URL shortener. And the last time we discussed that we have and generate a unique URL, short URL, and at the end we were at Redis INCR usage where there were some issues with that when the system scales up. So we tried to manage that by dividing it into multiple chunks and then distributing some IDs already in the system. But there were also some disadvantages to that there were some if the system crashes, the IDs are gone, something like that. Came up for a different solution, and that's a Snowflake solution where we have the timestamp in which the request entered, the machine ID, the system, the server ID, and the third one was the sequence number of the request. So we can combine all these three things, and it always makes sure that there would be no uniqueness. There would always be uniqueness, and that is how we generate a unique counter, and therefore a unique short URL. Now it is suggesting us two questions. Either we can compare Snowflake versus range based for the exact system. The Snowflake is this one, and range based is this where we store the range, or we can move back. I would prefer we can just simply read about it. We don't have to deep dive so much into it. So Snowflake ID styles are distributed ID generation algorithm, and let me do one thing. Right. So which combines a timestamp, machine ID, and sequence number in a 64-bit integer. The pros are scalability. It is highly scalable as ID generation is decentralized. See, we don't have a central entity, right, like Redis INCR that we had before. And it does not require a single central counter, avoiding a performance bottleneck. Exactly. And then the speed is also, it is a stateless process as each node can generate IDs independently, which is faster than coordinating with central database for the next available ID. Okay. And then we have unique ID. The combination of elements, timestamp, machine ID sequence ensures globally unique ID across a distributed system. So that's also a good thing. And then we have some cons. The complexity. The system design is more complex, requiring careful time synchronization between servers and unique machine IDs. Right. So the machine IDs should always be unique inside a single machine requests. The predictability. The generated short URLs can be somewhat predictable because part of the ID is known timestamp. True. True. If someone has the information, they would always have the information of timestamp of, no, they can't have the information of request ID or something, but if they can somehow grab that, that's a bad thing. Based IDs auto incrementing. The traditional approach uses a sequence of numbers, example a database auto incrementing primary key, to guarantee uniqueness, which is then encoded to base 62, right? So base 62 encoding plus counter. Pros: simplicity. It is simpler to implement, relying on built-in database features for generating unique sequential IDs. Right. It is because it is simply a counter. It simply does +1 +1. That's it. There is also a guaranteed Now the cons are centralized bottleneck. In a highly distributed, high throughput system where we have multiple servers and the throughput is very high, managing auto increment counter can become a performance bottleneck that we already discussed. Challenging to scale. It is difficult to scale horizontally, right? Because we have to divide it into multiple servers, and then we have to manage each of them so that uniqueness is maintained. So that's a tricky thing to do. Right. Exactly. Okay. So these are the comparisons. So I don't think we have to like dwell too much into it. We can continue to the Okay, let's see what it asks next. Okay, we have already logged ID generation to Snowflake's design plus base 62 or equivalent. Read heavy system 302 redirects, cache on read path. Okay. Question 5, high level architecture scoped. Explain only this. What are the major components of the system and how a request flows through them? Major components of a system, what? Oh, it means this URL shortener system. Okay. So, what are the major components of the system? How a request flows through them? I don't really get this question. Components का मतलब क्या हुआ यहाँ पे? Ah, okay, these things. Okay, okay. For this, let's imagine our system at scale. We are getting a lot of requests, so we will do horizontal scaling. This is how it works. It would look like, okay, at the very start we would have a was it what it is was it what is it called, a reverse proxy, is it, or API gateway, right? We can have an API gateway. It would point or redirect, not redirect, but point the request to multiple servers handling the URL construction generation. Similarly, we can have multiple servers for redirection too, since it is going to be read heavy. Okay, wait, if it is read heavy, do we need servers? I think we still need a server to just capture the request and then, ask the cache, etc., because it does not directly go to cache. It goes to the server and then goes to either cache or the database, depending on the situation. So yes, we can have multiple servers, right? And the request handled by API gateway will then be transfer to, wait, will API gateway come first or a load balancer? I think they work in combination. Okay, let's ask. API get do load balancing. Yeah, exactly. Right. In front of API gateways to distribute traffic evenly. Exactly. Okay, I was thinking that also. The request handled by API gateway will come to load balancers. Not come to, like, come on. Will be received by load balancers first. Balancer, just take one balancer, which will for it to multiple API gateways. Right. Depending on server's health, current CPU, current load, not CPU, server's health, current load, requests, but it came under load, etc. etc. is fine. Once request reaches a gateway or a server, it does the functionality in case of API URL generation. It does the computation in case of and make changes to DB. In case of redirection, it either contacts requests data from cache or database. We can have an async process for data analytics part 2. Why async? Because it is not a primary functionality and it can work is which would be efficient. Okay, I think that's all. We can maybe also mention, no, but it's fine. Yeah, cache detail में नहीं जाना है. Okay, let's see. Okay. So we divided the tasks into 2 sections. So that's a good thing, according to GPT. And you identified async analytics correctly. Analytics is non-critical. Async process avoids impacting latency. Yes, that's a good thing. API gateway versus load balancer confusion. You currently have this order. API gateway. No, I don't have this order. I have. अरे मैंने शायद एक्सप्लेन नहीं किया इसको सही से. वेट 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 वी डोंट हैव दिस ऑर्डर. लिखा तो मैंने. ओके इस चक्कर में इट गॉट कंफ्यूज्ड. ओके इसको फर्स्ट पॉइंट कर देते हैं. राइट right. Then we would have. Okay, now it should be fine. Okay, you identified the core components, load balancer, API gateway, then multiple backend servers, cache plus DB usage, async analytics. Correct building blocks. Okay, right. Okay, that's a good thing. Average load balancer versus API gateway confusion. Request API gateway. अरे क्या हो गया भाई इसको. यार छोड़ो. इसको कंफ्यूजन क्यों हो रही है. अरे ऐसा क्या लिख दिया मैंने. एडिट बटन कहाँ है. द रिक्वेस्ट will be received by load balancer first, which will be transferred to multiple API gateways depending on this. Okay, then we would have API gateway. The API gateway would point. इसका ऐसा लिखता है. API gateway would point the request to multiple servers handling the URL generation. ओके ये लिखते हैं. पता नहीं क्या बोल रहा है ये. Load balancer API gateway servers. In interviews, this can cause confusion unless clarified. Better phrasing: load balancer routes traffic to stateless application servers API layer. API gateway is usually used for authentication, rate limiting, request shaping. Not wrong, just needs clarity. Request flow could be slightly tighter. Load balancer, app server, then cache, then DB, then redirect. Oh, okay. I did not do this. Okay. What you did not miss, important. You did not miss anything critical for this question. You did not go into unnecessary detail. Did not over design prematurely. 8.5. See, last time we got 8.8, now 8.5. So that's a good thing. Okay. Cool. Now we have the next question, that is database design scoped. Explain what type of database you will choose, SQL or no SQL. Okay. Out of SQL and no SQL, I would choose SQL because it would be simpler to maintain and even see. It just needs a single table, maybe a table, maybe a few more tables for user, tire information, etc. to operate. Enable indexing to, right. So SQL we would be using what the primary keys. Oh, इतना भी जाना है. Primary key would be okay. So since we discussed that there could be multiple short URLs for, right? So let's take it this way. Excalibur draw. Okay, so short code will point to a long code, but there is this one thing that also came in this session we had yesterday, that there could be multiple short URLs for long URL. So there could be something like, if S1 is there and L, this is just L, right? There could also be S2 short URL2, and that could also point to L. There could also be S3 that could also point to L. In this case, if we put this as primary key, it would not be good for the table, right? So we would keep this as primary key. Oh, not code, it is not code, it's URL. Oh, but could we have the situation the other way around? Can we have long URL which points to short URL, long to, no, we can't have this situation. No, we can't have, because if we are putting this short URL in the URL section, then what it would point to, this or this? That's a conflict. Hence short URL is the primary key. Yeah, primary key, short URL. So automatic indexing 2. Okay, and one or two important indexes. Indexes. So indexing would first be what is it called? Short URL, which would be by default, since it is primary key. Another could be long URL, because while generating URLs, no, wait, right, while generating unique URLs, if we don't support multiple short codes for a long this is not code, URLs for a long URL, probably due to tier limitation, then we can search in the table using for the long URL if it exists already. In this case, indexing would be beneficial. Then we can, if we have tier, we will also keep a user ID column in the table, that this can also be index to show a dashboard to the user in the front end. For their short IDs and long IDs in the system. Right, so that's about important important indexings, and that's it. That's all it is asking. This is a calm, well-reasoned database. Answer and use stayed within scope. Simple schema, strong consistency, easy maintenance. For a URL shortener, SQL is perfectly acceptable choice, especially early on. Interviewers like when you don't overcomplicate. Yes. Right, okay. Indexing reasoning is logical. Primary key, secondary key, index on user ID for dashboard queries. Right. You tied database schema design to business rules, their limitations. Okay. Average needs improvements. Automatic indexing phrasing, you said. So automatic indexing too. And interviewers, it is better to say primary key automatically creates a clustered index. ठीक है, okay. Okay, reads are key based and simple, which also makes SQL viable. But SQL gives us strong consistency, the guarantee. Just acknowledging the alternative strengthens your answer. Okay, what you did not mention. Since I explicitly said no sharding, I won't reduce points for DB scaling limits, hot partitions. अरे भाई क्या क्या है इसमें? इतना सा क्वेश्चन है ये तो. 8.5 ठीक है. Okay, cool. Now comes one of the most important parts of URL shortener interviews. How redirection stays fast at scale. Role of cache. What happens on cache hit, cache miss? I think हम multiple time बात कर चुके हैं इसके बारे में, but it wants it in detail. So okay. Redirection stays fast due to multiple reasons which depend on the flow. A or 1. The request will go to API gateway first. This takes some time. Then API gateway. Okay, we are talking about okay, redirection, which is the second part, which is the read part, right? And do we need an API gateway for that? Do we need some kind of authentication? No, it's a public URL, right? I don't think we need API gateway for that. Okay, let's do something like this. But wait, it is second part of the application, which does not really need. Okay, if it does not, okay, so API gateway के और काम भी होते हैं, right? Rate limiting, etc. 8 gateway benefits या features. Security, right? Traffic management, routing, rate limiting, load balancing, circuit breaking. Okay, so let's just send it to API gateway. That is fine. That should be fine. Okay, I got interrupted. Um, an API gateway acts as a central entity for all these things, right? So even analytics. So yeah, that is okay. That is all right. Okay, so the API gateway will check the cache for the long original URL. If it finds it good, that's should be really fast. If it does not, which is cache miss, then it looks for that the long URL in the database. It could take more time, but we can make it one process by first finding it and then adding it to the cache. So next time cache is hit, right? Second role of cache is to keep frequently used or hot URLs in a fast memory so they can be accessed or fetched. TCHT, extremely fast. That's it. But slightly shallow answer. Okay, I thought so too. Cache hit fast, DB lookup plus populate cache, that is fine. Find it and then adding to the cache so next time the cache is hit. That is the right caching pattern. No unnecessary. Okay. API gateway confusion again. You said API gateway will check the cache. ओके API गेटवे बाद में फिर सर्वर को भेजेगा. कूल. मेरे को सोच रहा था बट आई थॉट बट ठीक है. Most traffic should be served from cache to keep latency low. Oh, ऐसा कुछ बोलना है. No mention of stalelessness. What stalelessness क्या होता है? Old data, right? In IT. Okay. All right. How to upgrade this to an 9/10 answer? Redirection is read heavy, so we optimize for cache hits. The request goes through a load balancer to a stateless app server. The app server first checks Redis with short URL to long URL. On cache hit, we immediately return a 302 redirect. On cache miss, we query the database, populate the cache, and then redirect. Okay. I think ये explicitly mention करना था. Okay, that is too much to say in just an interview. Okay, but ठीक है. If cache is unavailable, we fall back to the database to maintain availability. Okay, that is a good point. It's about articulation. सही बात है. That's a really nice answer. सारे क्वेश्चन इसके वेरी इंपॉर्टेंट होते हैं. What happens when the URL table grows to billions of rows? What happens when the URL table goes to billion of rows? One or two high level scaling strategies. ओके, बेस लॉग बेस टू पहले चेक करते हैं कितना होता है, बिकॉज लॉग बेस टू ही काम करता है उस पर इंडेक्सिंग पे. सो वी विल पुट बिलियन. 1 बिलियन में कितने जीरो? 9. 1 2 3 4 5 6 7 8 9. सो इट टेक्स 29 अटेम्प्ट्स. Hmm. 6, 7, 8, 9. The power of log base to C. Okay. Keeping billion rows in a table could look okay in first glance, considering the log base to search due to indexing will take 29 attempts. Not attempts, these are not called attempts, right? This is like what is it called? I forgot the term. So if we have 100 things and we need to search, so it divides it, right? But I'm forgetting the term. क्या होती है term? So in this case we can horizontally, we can shard the database basically, base in ways such that geographically where multiple shards database have keys or data have data according to the location. If the requested data is not found, only then it checks other shards. Range based, we can store 1 to 1 million in week jump to the optimal shard by a hashing algorithm, or just be a basic mod n. We can store 1 to 1 million in shard 1, 1 million plus 1 to 2 m in shard 2, and so on. Again, use a hashing algo to reach the correct shard. I'm not too much sure about this. Okay, let's think maybe. What else? So if the database is too long, you can do this. I think that is the only solution. Charting, like, what else can we do? We have to divide the database into multiple things. Yeah, that's the thing. Let's see. I know the answer is not that detailed, even I don't know much about it. This is a thoughtful scaling answer, and you are clearly reasoning instead of memorizing. I'll evaluate it. You did not panic at billion of rows. Mentioning log to lookup shows you understand the index mechanics. It is a good sign of fundamentals, but it is too much. Exactly right. Not because of lookup time alone, but because of storage, right, throughput, operational limits. हाँ, ये मेंशन करना चाहिए था, राइट. मुझे ये तो नहीं पता था स्टोरेज. या बट स्टोरेज भी काफ़ी हाई होगा. You proposed valid sharding strategies, geographical sharding, range based. Okay, I did not expect this answer to be good, but okay. Average things हो गए. Short URLs can be accessed from anywhere. Geo sharding creates cross region lookups in consistent latency. Correct. अगर data नहीं मिला optimal shard में, then we have to go to other places, and that is more latency. The strategy is more suitable for user profiles, region specific data. But yeah, in case of URLs, region specific, maybe even na ho. True. Range based sharding has a major hotspot issue. You did not mention new IDs always go to the latest shard, causes uneven load. Interviewers expect you to at least acknowledge this. Hashing or modern explanation is mixed. Range based routing via ranges, uniform distribution. Okay, these are important improvements. Hash based sharding by short URL. This is the best default for the system. Hash based sharding by default by short URL. So shard is equals to hash of a short URL mod n is the number of shards we have. Why interviewers like it? Uniform distribution, no hot shards, simple routing. True, ये mention करना था. Okay. Read replicas. You did not mention read replicas for redirect heavy traffic. Even one sentence like we can add read replicas since redirects are read heavy. What is read replica? Okay, last question is इससे पहले elaborate the 2 points improvement points you mentioned with examples. Then we will continue with next question. Right. So what geographic sharding means, data is split like US shard, URLs created in US, Europe, Asia. Okay. APAC कहते हैं इसको. APAC. What is APAC? Asia Pacific. Okay. Problem for URL shorteners. Short URLs are shared globally, clicked from anywhere, embedded in emails, social media ads. Examples: URL in India creates a short user in India creates a short URL. Linked is shared on Twitter. Users in US click it. With geo sharding, US requests hits USDB shard, but it is not available there. Right. Either cross region DB call high latency or request forwarding complex. Latency increases and architecture becomes messy. What when geo sharding does make sense? यूज़र प्रोफाइल्स ऑर्डर्स, यार मैंने ये पूछा था क्या इससे? मैंने इससे ये नहीं पूछा था. ये जो कि मिसिंग थे. अबे यार, मिसिंग पॉइंट से मेंशनड को ये पूछना है इससे, वो तो मुझे पता है. थोड़ा ये भी पढ़ लेते हैं, ठीक है, ओके. हाँ, Since short URLs are accessed globally, geosharding introduces cross-region lookups and inconsistent latency. It is not ideal here. Cool. Improvement point 2: hot shard problem in range-based sharding. Hot shard. Right, 1 to 1 million. Oh, I see what it means. So it is saying if we create new IDs would obviously be starting from 3 million to this. So all the data, the frequent data will go in here, right? The most recently created, exactly. Okay. अच्छा इसने मेंशन किया है. ओके. What interviewers prefer instead: hash based sharding. Example: ABC points to ये shard 0. This why it's better. Okay, so instead of range based, right, it is saying hash based. Uniform distribution, no hot shards, global access friendly. Okay. How is the hash created? Pointing to shards even. How? Every application server knows a deterministic mapping from key to shard. Okay. Shard 0, shard 1, shard 2, we assume we have these 4 shards. Apply a hash function. We run a hash function on the key. This could be murmur hash, okay. Modulo by number of shards. राइट, ये तो सजेस्ट किया था मैंने. बट ये वाला हैश कौन सा है? अच्छा, ये ऊपर वाले. ओके, सो दिस एंड मॉड समथिंग राउट रिक्वेस्ट. दैट्स इट. नो DB स्कैनिंग, नो क्रॉस हार्ड लुकअप. वेयर इज द लॉजिक इम्प्लीमेंटेड? ऑप्शन 1 इनसाइड द ऐप सर्वर. अरे बट हाउ डज इट मेक श्योर कि यूनिक ही मिलेगा उसको शार्ड? Oh, the hash algorithm maintains it. Okay, so when we are putting the information, okay, I did not consider it. Okay, so when we would always obviously be putting the information in the shard. So while putting the information, we all again have to choose the shard out of 4. So when we do that, while choosing the shard, we will take the hash algorithm, put the short URL in the hash algorithm. We would get something back, right? And then if we would be doing modulo 4, okay, then it would point to shard 1. Same thing will happen while reading also. Okay. Exactly, my question was going to be this. Yeah. Problem with simple modulo, if shard changes from 4 to 5, everything is changed, right? Almost all keys remap, massive data reshuffling, solution consistent hashing. This is called consistent hashing. Cool. Hash both keys and shard onto a ring. Ring. Key goes to the next clockwise shard. Shard 1, shard 2, shard 3. Keys stored हैं इसके अंदर. Adding, removing a shard only moves 1 by n keys. Approximately 1 by n. Example. Shard 1 में 20 keys stored हैं, 50 keys और इसमें 80 keys. Right? And 65. Oh no, it is not keys. The amount of keys नहीं है ये. But it is just a hash value. Okay. So this generates hash 65. So we'll go to this. No. Then we'll go to maybe this. Shard 3 next clockwise, right? So we can assume that 50 से 80 इसके अंदर स्टोर होंगे, 20 से 50 इसके अंदर एंड 0 से 20 इसके अंदर. Something like this. ये सब नहीं करना, छोड़ो. Continue with the next question. Leave follow up question. Okay, let's see. What happens if cache goes down? What happens if 1 dB shard goes down? Okay, let's answer these questions. If goes down, all the requests will eventually go to the DB. For small scale, it could work. It would be slow, but could work. But at scale, it would with too many requests could lead to 2 dB crash, both reads as well as writes. What happens with 1 dB shard goes down? If 1 dB shard goes down, if 1 dB shard goes down, okay, we can assume we have 4 shards, and in each shard we have, I don't know, 100 keys. If 1 dB shard goes down, the data or keys stored in that shard are no more accessible. This causes system unavailability. How does the system remain available? Okay, that's a good question. Okay, if sharding fails, if 1 shard fails, not sharding, we can have a system detection which detects detection strategy, maybe more like, which detects if the shard is down in in such case, okay, if the shard is down, so do we have the data somewhere else? I'm not sure how this will work, but this is what I came up with. I would be keeping backup of data. So shards are the primary storage units, but I have copies too, copies of data too. Maybe at a central place, combining all shards data. Then we can have a detection strategy which detects if a shard is down. In such case, we can either activate a new shard, which I am assuming could be expensive, could be time taking, or maybe not possible, or a better way could be to transfer data of failed shard to shard +1 in the consistent hashing circle. So if the data is not found, or due to failed shard, the request goes to next shard by design, and it finds the data there. But I guess the problem then would be of storage, because I think the shard will have some limited storage for its use only. We can also attach a copy with each shard, just in case it fails. Yeah, that is manage of more data, keeping it consistent. But we can make it, we don't have to keep it consistent. What is that term? Live, at real time, since we can make it async or job based. This will keep system available. I don't know, let's see क्या होता है. This was a hard question and you handled it with honesty and real reasoning. ठीक है. Correct identified cache failure impact. You clearly said cache down is equals to db load spike at scale, db overload, and cascading failure. This is 100% correct and very important insight. You understood shard failure consequences. Data or keys stored in that shard are no more accessible. Right? You reasoned your way to replication even though you weren't sure. You arrived at right direction. Data copies, direct detection, failure, replica, failover, replica per shard. This is a very good sign. Interviewers care more about directionally correct thinking than perfect wording. ठीक है हाँ. Correct backup idea is not practical. Central backup idea is not practical. Central place combining all shards data. This creates bottleneck. single point of failure, huge operational complexity. Backups is not equal to availability. Okay. Consistent hashing failover logic was mixed. You said go to shard plus one in the circle. This only works if data is already replicated there. अच्छा मैंने मेंशन नहीं किया क्या कि हम रेप्लिकेट कर देंगे वहाँ पे? ओह ओह रुको रुको मेंशन करते हैं इसको. अरे मैं तो लिखना भूल गया. थोड़े पॉइंट्स ज़्यादा मिलेंगे, मे बी 0.5 ही सही. और बेटर वे टू ट्रांसफर डेटा ऑफ फेल्ड शार्ड. अभी लिखा तो है मैंने, शार्ड प्लस वन इन द कंसिस्टेंट हैशिंग. Yes. I know it is still incorrect, but दिखते हैं. ठीक है. Attach oh, this was the answer. Attach a shard copy with each shard. Oh, central backup of all shards is not ideal. ठीक है, cool. Backups are for disaster recovery, not availability. ठीक है, cool. That's a good point. Moving shard data on failure is too slow. Okay, during copying traffic is still failing. Storage mismatch. You noticed this yourself. Good instinct. Cache replication rate limiting. Graceful. Oh, ये क्या है? Cache replication. Replicas of cache. हाँ. क्या मतलब? उसका भी cache. Let's see क्या बोलता है ये. Cache goes down. What happens? App server bypass cache requests directly go to database. Now availability is preserved. Cache is replicated. Redis primary plus replicas. How availability is preserved? Cache is replicated. Automatic failover. DB is protected by rate limiting and circuit breakers. Okay, we can protect it from overload. Cool, but what happens if the data, too much requests are coming? Then, okay, it's about shard. 1 DB shard goes down. Correct strategy: replication, primary plus replica. Each shard 1 primary, shard 1 replica A, replica B. Reads go to replicas, writes go to primary. On failure, oh, इस तरह से reads go to replicas. On failure, replica is promoted to primary. Routing table updates. No data movement required. No waiting. How the system remains available? Availability is preserved by cache replication, DB shard replication, health checks plus failover, stateless app servers. Data backups are for data loss, region-wide disasters. Before moving ahead, I understand the DB can be prevented from overload by Why rate limiting? अरे यार, but doesn't that mean not? So system is unavailable. Okay. Okay, rate limiting. Okay, cool. Availability is not 100% availability. It's as best as we can do. Cool. Okay. 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 We can move ahead. क्या बोलना है पर आगे उसको? हो गया भाई, कितना पूछेगा ये? Oh, you mean next question? You gave me a... Don't move to next question now. Were those the only in and you know what? Functional and non-functional we discussed. High level architecture, ID short URL generation, cache strategy for redirection, database schema indexing कर लिया है, database scaling sharding, reliability and fault tolerance, read heavy performance optimizations. Okay, सब हो गया है. Cache eviction and TTL, time to, क्या होता था TTL? time to lie? नहीं, TTL की फुल फॉर्म क्या थी? time to live. How do you keep URLs in cache? No, obviously no. Okay. Now, myself, but I need नहीं, क्या स्पेलिंग होती है इसकी? Okay, and one more thing. I would also more send. Do you also face this issue with GPT? जब content बहुत ज़्यादा हो जाता है, it does this weird thing. कितना टाइम हो गया हमें स्ट्रीम करते हुए? 1:14. The one page rule, very important. One page is equals to one system is equals to one page max. Okay. If it does not fit on one page, you're writing too much or writing at a wrong level. The ideal structure, use this template, problem statement, 2-3 lines, answer. What is being built? At what scale? No features list here, just intent. Core requirements, bullet only, split into functional, max 4 bullets, non-functional, max 4 bullets. Okay, write components only, load balancer, app servers. अब नोट्स बनाना भी सीखना पड़ेगा. ठीक है. Okay. Okay, shall we make notes? Docs में बनाते हैं. Right, and इस तरह से करते हैं इसको, and let's see one by one. Okay. So we have to contain it into one page. ठीक है, cool. Although अगर हम properly ऐसे formatted लिखेंगे तो मे भी नहीं हो पाएगा, but let's see. All right. What is being built? अरे ये क्या कर रहा है यार? What are we building? A URL shortening service for at of 1 million read requests. I don't know, let's say 10 million read requests. 10 million could be too much, right? 10 million read requests and 10 million and 1 million read/write requests. Okay, that's it. What are we building में? That's it. Nothing more. This is the intent. And functional, requirements. Long URL generation, long to short URL redirection, short to long, right? And wait, yeah, I'm back. Okay, so functional requirements are these two things mainly: data analytics, clicks, geodata, etc. URL clicks or hits, whatever. Okay, fourth क्या है? और क्या था functional? Even I forgot. Okay, see, notes making is so important. Long URL. Okay. What else? टायर बेस्ड कर दें क्या इसको? टायर बेस्ड सब्सक्रिप्शंस आई थिंक काफ़ी है, फंक्शनल में काफ़ी है. एंड नॉन, इसने क्या बोला था फंक्शनल में जो हमारा इशू था? अरे कैश नहीं, यूआरएल एक्सपायरी, यूआरएल पॉज स्लैश एक्सपायरी एट्सेट्रा. ठीक है, नॉन फंक्शनल रिक्वायरमेंट्स में आ गया. अवेलेबिलिटी, consistency and latency, 50 ms for writes and अरे इसको ये डालो, less than 50 ms for writes, less than 10 ms for reads. Okay, what else? कंसिस्टेंसी का आई रिमेंबर इसने कुछ अलग बताया था देन व्हाट वी आंसर्ड, राइट? कंसिस्टेंसी का इट टोल्ड, राइट, राइट, consistent read after write. Okay, what else do we have? um Durability. Let's write something about durability. URLs. Okay, even if a cache fails, data should survive. In case node या cache या shard failure, right? This is fine. Let's write one line for each of them. Availability. System should generate and redirect URLs all the time. Consistency is this thing where it should always map to, right? I said this. Okay, I keep forgetting this, but incomplete, right? Okay, I think this is fine, right? Non-functional maybe. Was there something else? Security. Security भी लिख देते हैं. URL can predict ABI could lead to right. ठीक है, काफ़ी है ना. Like main points काफ़ी हैं, right? So that's about non-functional requirements. अरे यार, तो द लगा दे भाई. Okay. High level architecture. High level architecture. Okay, load balancer. Balance the load distributed servers. Load balancer app servers where we transferred cache to access for fast retrieval. ये तो मैं डिफाइन कर रहा हूँ इस चीज़ को, राइट? ये सब, हाँ ये सब, हाँ राइट, ये सब चेक कर. फास्ट रिट्रीवल एक पॉइंट लिख दिया अगर. अरे यार फिक्स करो स्पेलिंग. फास्ट रिट्रीवल ऑफ डेटा डीबी. हाँ ये सब की ज़रूरत नहीं है भाई, मैंने लिख रहा है ये सब. दिस इज टू मच इन्फॉर्मेशन. नॉट टू मच, दिस इज़ वेरी ऑब्वियस इन्फॉर्मेशन. ये कौन लगता है? डीबी हो गया एंड एसिंक फॉर डेटा. Data analytics or cache, what do you call it, cache fills, updates. Yeah. Critical design decisions. Okay. Why this ID design strategy? This base 62 plus unique easy to no I think base 62 encoding. I don't think we went for base 62 encoding. We I think went for snowflake design. Why snowflake design ID generation strategy? Easy to implement. Easy to implement. No on a centralized unique counter like Redis INCR. Reddick नहीं Redis. अरे भाई तो कैसे करूं? Why this DB choice? Wow. Why this DB choice? SQL. Easy to. Why SQL DB choice? Because simple and consistent schema उसने क्या मेंशन किया था NoSQL के बारे में? Okay. Simple and consistent schema. That's it. और क्या लिखे हैं SQL के बारे में? Why cache here? Why caching is used? Because reads are else and don't change rarely. Reads are high in. अरे क्या लिखूं? Reads are very high number and don't really and URL data doesn't really change. अच्छा क्या इंग्लिश लिखी है? Reads are very high in number and URL data changes rarely. What else? That's it. फालतू नहीं लिखना. Why async here? Data is a additional or functional which on being async will be efficient, will be highly efficient, will. Okay, that is not how I want to frame it. Will be more efficient in sync. Okay, that's it. अगर हमने एक पॉइंट से लिखे हैं तो ऐसे लिख देना उसको बेवकूफ़, राइट? ऐसे लिख दे गधे. डिलीट एंड उस पूरा को ही बोल्ड कर देते हैं. Right, okay, that looks good. Okay, then we have scaling and reliability. For scaling, we are using we are using horizontal right, we were using geographically located servers. Did we use range-based, hash-based sharding? sharding, right? For an evenly distributed system, right? Uniform distribution. No hot shards and simple routing. ये खुद के लिए लिखना है मेरे को. Hash on will store the data in shard X, will also it from shard X using same hash function while on reads. My mic was mute. Extremely sorry guys. कोई देख नहीं रहा वैसे इस लाइव को इस टाइम पे, बट फिर भी सॉरी. ओके, वाई दिस आईडी जनरेशन स्ट्रैटेजी. ओके, ये वाला हो गया है. वन स्केलिंग बॉटलनेक. Scaling bottleneck was single data. यार इसको ऐसे करते रखो, पहले इसको यहाँ डालते हैं. राइट, सिंगल डेटाबेस too much data, 1 billion rows. Right, reliability risk, reliable. Data shard failure. Reliability risk, data shard failure, which is why we are using data replicas which will work on shard failure. Right, one mitigation. Okay, I think this is fine. Okay. Okay, I'm not sure क्या लिखूँ उसके में मैं. What you deliberately did not optimize. What would you change at 10x scale? Oh, these are very difficult questions यार. 10x scale में मैं क्या change करूँगा? Will divide data into more shards. Vertical scaling to हाँ इसमें लिख सकते हैं हम did not focus because our use case was not really computationally expensive. नहीं बट अगर नहीं वर्टिकल स्केलिंग में नहीं डिवाइड इनटू मोर शार्ट्स will work more on cache failure cache failure. ओके आई डोंट नो ट्रेड ऑफ इससे पूछ लेंगे एक बार इसको दे देते हैं ये राइट हियर इज व्हाट आई आस्क्ड व्हाट आई रोट I could not think much about the last section. Help me in that. Refine what I wrote with as less changes as possible. And give feedback also. ओ 1 2 3 गए नहीं इसमें कोई नहीं पढ़ लेगा क्या है ठीक है इसने क्या चेंज किया URL शॉर्टनिंग सर्विस डा ठीक है सब तो सही नहीं है स्केल्स हॉरिजॉन्टली इजीली राइट ये पॉइंट नहीं लिखा था ओके ठीक है, ओके, नॉट बैड. Clear separation of requirements and decisions. Okay, strong signal to noise ratio, no fluff. Design decisions are opinionated and justified. This already reads like an SGG2 level thought process. Okay, ठीक है. Tightening wording without adding complexity. Trade-offs section now feels intentional, not forced. Why this works on LinkedIn? Scannable in 2 minutes, 2-3 minutes. Okay. Final advice before posting. If you post this on LinkedIn, add one line, opening line, and why you did this exercise, and with one reflective line. Okay, do this. ये सब इससे बोलते हैं, राइट? हमने काफ़ी हद तक कर दिया है. ओके, तो एक काम करते हैं दोस्तों, कोई देख नहीं रहा वैसे, बट दोस्तों हाँ, लाइव बंद करते हैं. आई थिंक 1.5 घंटे से ऊपर हो गया है, 2 घंटे होने वाले हैं, तो दैट्स अ गुड थिंग. सो इतना बेसिक टॉपिक को हमने इतनी डिटेल में किया. आई थिंक दैट शुड बी द गोल फ्रॉम नाउ ऑनवर्ड्स. वी विल अगेन स्टार्ट विद दिस नेक्स्ट वीक. मे बी वीक के बीच में भी हो सकता है, आई एम नॉट श्योर, बट नेक्स्ट वीक सैटरडे डेफिनेटली. एंड आई विल ऑल्सो लिंक दिस चैट, ऑल्दो कोई देख नहीं रहा है, बट स्टिल खुद के लिए भी कि एकदम डायरेक्टली वहीं पे मुझे लिंक मिल जाए इस चीज़ की. अरे कल करेगा क्या? हाँ ठीक है, चल कॉपी लिंक, राइट. डिस्क्रिप्शन में डाल देते हैं, पहली वाली वीडियो में भी डाल देंगे. हाँ, पर डिस्क्रिप्शन है कहाँ पे? ओके, ओके, ये वेरिफिकेशन भी कर देंगे, अभी नया अकाउंट है मेरा ये. एंड व्हाट एल्स, आई विल पोस्ट दिस ऑन माई लिंक्डइन. लिंक्डइन में कुछ टाइम में दे देंगे यहाँ पे जो भी है, राइट. एंड ओके, दैट्स इट.